Today we'll talk about polynomials and their graphs. Some of the examples of polynomial functions that we're already familiar with are f of x equal to x squared, x cubed, and so on. These are some of the simplest polynomials. But today we'll talk about higher degree polynomials. So an example of a higher degree polynomial could be p of x equal to 2x to the fourth minus 3x squared plus 5x minus 1. The graph of the polynomial is always a smooth curve. In general, we write a polynomial as Now what is a sub n? A sub n is known as the leading coefficient. Whenever we write a polynomial, we always write it in decreasing powers of x. So your first term, the coefficient of the first term is a sub n. What about a sub 0, the last one? That's known as the constant term, the one we write at the end without an x. What about the degree of the polynomial? When we write it in decreasing powers of x, the degree is the highest exponent. In this case, it would be n. Let's talk about the n behavior of a polynomial. The n behavior of a polynomial is what happens to the polynomial graph as x grows large in the positive or in the negative direction. So let's look at the graph of y equal to x squared and talk about the n behavior. So what is happening? As x is growing large, y is also growing large. As x is going in the negative infinity direction, y is also going up. Right? What about x cubed? What's the n behavior like? In this case, one end is up, one end is down. Whereas in y equal to x squared, both ends were up. So in y equal to x cubed, when your x is increasing in the positive direction, your y values are increasing in the positive direction. When your x values are in the negative direction, your y values are also in the negative direction. So we call this raising to the right, and this is both ends up. So one side down, one side up. This is both ends up. We can also talk about the degree of a polynomial and the n behavior. So whenever your the degree of the polynomial is even, then you have a graph that is like this, or a graph that's a parabola that's open downwards. So here we talked about this before, where the coefficient is positive, and here where the coefficient is negative. So in this case, for us, it would be the leading coefficient. When your n, the degree of the polynomial, is odd, then you have a graph, if it was y equal to x cubed, going this way with a positive coefficient. If you change the coefficient to a negative sign, then it would go the other way around. So this is y equal to negative x cubed. This was y equal to positive x cubed. One of the other properties of a polynomial can also be based on the number of turning points. So the degree of the polynomial is related to how many times the graph of the polynomial turns. So if the degree is n, then the number of times a polynomial could turn is at most n minus 1. So your turning points would be n minus 1. So if my function was f of x equal to x squared, the degree is 2. So the number of turning points would be 1. That means the graph of y equal to x squared will turn once. And we already know that the graph of a parabola has one turn. Now let's look at the graph that we see here on the screen and see if we can identify some properties. So one of the first things we try to see is, based on the shape of the graph, if we can tell what the degree of the polynomial would be. Now think about y equal to x squared. That was a parabola that was open upwards. This one is a parabola that's open downwards. But we know that there is 3 turns. So the number of turning points is 3. So that means the degree has to be 4. Because 3 turning points would give us, a degree of 4 will give us n minus 1 turning points, which is 3. What about the leading coefficient? The leading coefficient is a sub n. In this case, both ends are pointing downwards. So think about y equal to negative x squared. So the leading coefficient is going to be a sub n less than 0. Remember, we don't know what the equation for this function is. So we are going to try to see if we can come up with some properties of what that function would look like. So number of turning points equal to 3. Now yes, we can write the domain, we can write the range, we can also write what the minimum value is and what the maximum value is, but that's for another time. Zeros and multiplicity is another property of the polynomial functions that will help us draw the graphs. So 0 of a function is nothing but what? The x-intercept. The multiplicity is simply the number of times the 0 occurs. So for example, if I have a function f of x equal to x plus 3 whole squared, this means the 0 of the function is when f of x is equal to 0. So we would get x plus 3 equal to 0, or x plus 3 whole squared, and the square goes away. We get x equal to negative 3. So this is nothing but the 0 of the function. Now the multiplicity is how many times does the 0 occur. We see that x plus 3 whole squared means the 0 is twice. So we have 2x plus 3. So x equal to negative 3 has a multiplicity of 2. Let's look at another example. So let's say we have f of x equal to 2 times x plus 1 whole squared and x minus 2 whole cube. Now how many zeros do we have? So the zeros are obtained by setting each factor equal to 0. So we get x equal to negative 1 and we get x equal to 2. Now x equal to negative 1 will occur twice because we have x plus 1 whole squared. So the multiplicity here is 2. And for x equal to 2, we have x minus 2 whole cube. So the multiplicity here is 3. So what this helps us to do is, when we think about the graph of the function, if we have an even multiplicity, then the graph is going to touch at that 0. So here x equal to negative 1 is an even multiplicity. So the graph is going to touch. When you draw the graph of this function, the graph touches at x equal to negative 1. The odd multiplicity is for x equal to 2. So in this case, the graph is going to cross at x equal to 2. And you can use a graphing calculator to draw the graph of this function and verify if that is true or not.